Parametric differentiation for the curve given in the parametric form x equals f of t and y equals g of t. dy dx equals dy dt multiply dt dx, which equal dy dt divide dx dt, where f and g are two differentiable functions with respect to t. What that mean? If we have a curve defined by these two equations, x equals f of t and y equals g of t, these two equations represent the equation of the curve, but we wanted to calculate dy dx. So dy dx equals dy dt multiply dt dx. How we get it? It is equal dy dt divide dx dt. So finally, when you want to calculate dy dx like this, so first we will find dy dt and dx dt, and we will make a division. dy dt divide dx dt. For that we'll take some problems. Find dy dx for the following curves at the given values. A. We'll start with A here. X equals t plus 7 multiply t minus 2, and y equals t square plus 1 multiply t minus 2 at t equals 1. And the required here is to find dy dx. Okay, first we will calculate here A. First we will calculate dy dt. Using the given, we have y equals t square plus 1 multiply t minus 2. It is the product of two functions. So dy dt we will differentiate with respect to t. The first function, it's t square plus 1 multiply the derivative of the second function, the second bracket. The derivative of t is 1 minus the derivative of 2 is 0, plus the second, which equal t minus 2 multiply the derivative of the first function, which equal 2t plus 0. So we'll simplify the result. It will be t square plus 1 plus t multiply 2t, it's equal to t square minus 4t negative 2 multiply 2t equals 4t, and we will arrange it. It is equal 3 t square minus 4t plus 1, and this is first step. Dy dt equals 3t square minus 4t plus 1. Second step, we calculate dx dt, which equal x equals t plus 7 multiply t minus 2, the product of two functions, the derivative of the product of the two functions. The first, it's t plus 7 multiply the derivative of the second, which equal 1, plus the second function t minus 2 multiply the derivative of the first, which equal 1 also. So the result equals t plus 7 multiply 1 equals t plus 7 plus t minus 2 multiply 1 equals t minus 2. and we simplify it. T plus 2 t plus t equals 2t plus 7 minus 2 equals 5. And here is the second step. Now we will calculate dx dy dt. As we said before, now we will calculate dy dx. dy dx equals dy dt divide dx dt from the first definition here. So it is equal, we make a fraction. In the numerator we will write dy dt. dy dt, the final form is 3t square minus 4t plus 1 over dx dt, which equal 2t plus 5. 2t plus 5. Of course, t not equal negative 5 over 2. Here the required here is to find the dy dx when t equals 1. So substituting t equals 1, what we get? dy dx when t equals 1 equals 3 multiply 1 square minus 4 multiply 1 plus 1 over 2 multiply 1 plus 5, which equal, you can use your calculator. We have here 3 multiply 1 square, which equal 3 minus 4 equals negative 1. Negative 1 plus 1 equals 0 over 7. So the result equals 0. B, we have x equals 6 square theta minus 1, y equals tan theta, and theta equals negative 3 pi over 4. And the required is to find dy dx. What is the value of dy dx when theta equals negative 3 pi over 4? First, we calculate dx d theta, which equal 2 sec theta multiply the derivative of sec theta itself. The derivative of sec is sec tan, sec theta dot tan theta, and we arrange it equals 2 sec square theta as sec theta multiply sec theta equals sec square theta dot tan theta. And this is the first step. Now we must calculate dy d theta. dy d theta equals, we have y equals tan theta, and the derivative of tan theta with respect to theta equals sec square theta. Now dy dx equals, it's the rule, dy d theta divide dx d theta, which equal, we put it in a fraction, dy d theta, it is the numerator, which equal sec square theta, over dx d theta, which equal 2 sec square theta dot tan theta. And we can simplify it, dividing up and down by sec square. We will get in the numerator 1 over 2 tan theta. Now when theta equals negative 3 pi over 4, then dy dx equals 1 over 2 multiply tan negative 3 pi over 4. And now we will convert 3 pi over 4 to degree measure, and negative 3 pi over 4 equals negative 3 multiply 180 all over 4, which equal negative 135 degrees. We substitute pi equals 180, so negative 3 pi over 4 equals negative 3 multiply 180 over 4. 180 over 4 equals 45, multiply negative 3 equals negative 135. Now substitute theta equals negative 135, so dy dx equals 1 over 2 multiply tan negative 135, which equal, now we will calculate it using calculator. Half. See, now find dy dx when t equals 2. So first we will calculate dx dt. Here we have a root, and the x is a function in t, so dx dt equals 1 over 2 multiply the root 3t minus 2 multiply the derivative of the quantity inside the root, and the derivative of 3t minus 2 is 3 minus 0. The derivative of 3t is 3, so we simplify it. It will be 3 over 2 root 3t minus 2. Now we calculate dy dt. Dy dt equals, it is the same rule for differentiation, the square root, 1 over 2 multiply the root itself 4t plus 1 multiply the derivative of the quantity inside the root. The derivative of 4t is 4 plus the derivative of 1 is 0. So the result equals 4 divided 2 equals 2 over root 4t plus 1. Now the required is to find the dy dx, and the dy dx equals dy dt divide dx dt, which equal dy dt, it is 2 divide root 4t plus 1 divide dx dt, it's 3 over 2 multiply 3t minus 2 root 3t minus 2, which equal 2 over root 4t plus 1 multiply, we write the reciprocal of this fraction, it is 2 root 3t minus 2 over 3. Now substituting t equals 2, so dy dt dx, sorry, dy dx when t equals 2 equals 2 over root 4 multiply 2, it is 8 plus 1 equals 9 multiply 2 multiply root 3 multiply 2, it is 6 minus 2 equals 4 over 3 equals 2 over 3 multiply root 4, it is 2 positive 2 multiply 2 equals 4 over 3, and the result equals 8 over 9. Find the value of the parameter z at which the curve x equal 2z power 3 minus 5z square minus 4z plus 12 and y equals 2z square plus z minus 4. First has a horizontal tangent and another vertical. So we have two cases. A, when the curve here, it is the first case when the curve has a horizontal tangent. Second case, when the curve has a vertical tangent. We start with A. First, we must calculate dx dz, and we calculate dy dz, and then we will obtain dy dx. Okay, this is the steps of solution. Now dx dt equals the derivative of 2z power 3 equals 6z square minus 10z minus 4, and the dy dt equals 4z plus 1. So dy dx equals dy dz dz, yes, divide dx dz, which equal dy dz, it is 4z plus 1 over 6 z square minus 10z minus 4. Now A, when the curve has a horizontal tangent. When the curve has a horizontal tangent, it means dy dx, it is the slope of the tangent, equals 0. When the tangent is parallel to x-axis, horizontal, so its slope equals 0. So for z plus 1 over 6 z square minus 10z minus 4 equals 0. That means the numerator equals 0. 4z plus 1 equals 0, and the parameter z equals negative 1 over 4. Now when the tangent to the curve is vertical, what that mean? dx dy equals 0, implies 6z square minus 10z minus 4 over 4z plus 1 equals 0. So 6z square minus 10z minus 4 equals 0. And we will make a factorization by taking 2 as a common factor. So we have 2 multiply 3z square minus 5z minus 2 equals 0. Now we will factorize 3z square minus 5z minus 2. So we have 2 multiply the product of these two brackets equals 0. 3z square equals 3z multiply z, and 2, it is 1 multiply 2. Here is negative and here is positive. So 3z plus 1 equals 0. It means z equals negative 1 over 3. And when z minus 2 equals 0, it means z equals 2. Now use the parametric differentiation to find the derivative of x minus sine x with respect to 1 minus cosine x at x equals pi over 3. Solution: let y equals x minus sine x and let z equals 1 minus cosine x. So the required is to find dy, dz. Now we calculate dy dx equals 1 minus cosine x. The derivative of sine x is cosine x, and dz dx equals the derivative of 1 is 0 minus the derivative of cosine x is negative sine x. So dz dx equals positive sine x. Now the required is to find dy dz. So we write dy dz equals dy dx divide dz dx equals, here is the fraction, dy dx, we calculate it, it is equal 1 minus cosine x over dz dx, which equals sine x. Now substituting x equals pi over 3 and pi over 3 in degrees measure equals 180 over 3, which equal 60 degrees. Now dy dz when x equals 60 equals 1 minus equals root 3 over 3, and this is the final answer.